In this example, we're taking a look at the indefinite integral of x over 1 plus x squared dx. So again, I'm going to look for my inside function. Okay, in this case, it's going to be the part in the denominator. So 1 plus x squared there in the denominator. That's going to be my function u. So u is equal to 1 plus x squared. Now when I take my differential du, I'm going to take the derivative of my function. So the derivative of 1 is 0. And then when I take the derivative of x squared, I bring the 2 down, decrease my exponent by 1. So 2x to the first power, okay, times dx. All right. So now notice, okay, I have 2x dx. But when I take a look at my original function, all I have here is x dx. So again, I have a case where right now I have a coefficient that doesn't show up in the interval. So there is no 2 in the integral. So I have to get rid of it. And the way that I do that is I'm just going to divide both sides by 2. So I wind up with 1/2, whoops, not 1/5, 1/2 du is equal to x dx. So now my x dx matches with what I have actually inside my indefinite integral. So I can go ahead, I can rewrite this as the integral of 1/2. I don't know why I keep wanting to write 1/5, but 1/2 times 1 over u du. Okay, and so when I take the indefinite integral, I know that my 1/2 is going to stay because it's just a coefficient. Then the integral of 1 over u is the natural log of the absolute value of u plus c. And then my last piece that I need to do is to replace u with the function it represents. So this is 1/2 times the natural log of 1 plus x squared plus c as my answer. All right. Now then, this next example here, okay, I've got the integral of 3t over 3t squared plus 1 to the 4th power dt. So what I am going to do first here is I am going to rewrite this, okay, whereas instead of having my function down in the denominator, I'm going to bring it up to the numerator with a negative exponent. So I have the integral of 3t times 3t squared plus 1 to the negative 4th dt. Okay. And when I take a look at this, I can see that my inside function is 3t squared plus 1. So when that's what I'm going to set u equal to, 3t squared plus 1. And when I do my differential du, I take the derivative of this function. So 2 times 3 is 6t plus 1. The derivative of 1 is 0. And so I have 6t dt. Okay. Now when I take a look at what I have in my integral, I have 3t dt here. Okay? Not 6t. So in order to get from 6 down to 3, I'm going to have to divide both sides by 2. So when I have 1/2 du, that's going to be equal to, well, 6 divided by 2 is 3, and that's going to give me my 3t dt, okay, that actually shows up in my integral. So now I can go ahead, I can rewrite this as the indefinite integral of u to the negative 4th times 1/2 du. And I'm going to go ahead, I'm going to take that indefinite integral. So the 1/2 is just a coefficient. I can write that out in front, 1/2. And then I'm going to be multiplying it by, now I take the exponent and I add 1 to it. And then I take, in the bottom, put the exponent plus 1 in the denominator, okay, plus c. So this is going to be 1/2 times, well, u to the -4 plus 1 is u to the -3 over -3 plus c, just like that. So now when I do this, I am going to have 1/2 times 1 over -3. So I have -1/6 u to the -3 plus c. And finally, I'm going to go ahead, I am going to replace u with the function it's equal to. So -1/6 times 3t squared plus 1 to the -3rd plus c. And then my last bit that I need to do is I just need to rewrite this in the same form as my original integral. So this is going to become -1/6 times 3t squared plus 1 to the 3rd power plus c as the solution for this problem. Now one more example in this group. We'll do the integral of e to the -0.01x dx. So again, I'm looking for my function that's on the inside in an exponent in parentheses, and I can see that -0.01x is going to be my function u. So u is equal to -0.01x du, my derivative, my differential. Okay, I take the derivative of this. This is going to be -0.01 dx. But notice that all I have in this function is just dx. So what I need to do is I need to figure out what I need to multiply by in order to convert -0.01 dx into just dx by itself. So in order to do that, what I am going to have to do is, well, I can divide by -0.01 on both sides, -0.01. Okay. But realize that when I do that, 1 over -0.01 is the same thing as multiplying by -100 du is equal to dx here. So I can rewrite my integral now as the integral of -100 e to the u du. And when I take that, the coefficient of -100 stays the same. The integral of e to the u is just e to the u. And I can't forget my plus c, my constant of integration. So now I'm going to replace e to the u with what u is equal to. So -100 times e to the -0.01x plus c is my solution to this indefinite integral.